Assalamualaikum students. Today our topic is lenses, and it's really just like the one we've studied earlier, like mirrors. Okay, so first got to know what is a lens. Any optical device or any optical material which is transparent in nature and is used to focus or disperse a beam of light by refraction. Okay, so what was the principle behind mirrors? It was based on reflection. Okay, but lenses are based upon refraction. That's why there are little, differences between them. Okay, so first we're gonna discuss what is a concave lens and what is a convex lens. Okay, so now let's consider two spheres like this. Remember, we've discussed about sphere that in the case of mirrors, that we took one sphere and we cut out one small circular piece from it and we called that mirror. But in this case, we're gonna just consider two circles. Okay, each having the same radius. Now if we place these spheres or these circles like this, such that their middle part, okay, the spacing between them and its middle part is quite thinner than these edges, then it will be called as a concave lens. Okay, you can see the space between these two circles. Here the central part is thinner than the edges, then it is called the concave lens. You can already see the caves made here. Okay, so here it look like a concave lens, and from here again it looks like a concave lens. All right, next is convex lens. Okay, so now we're not gonna just put these two circles apart, we're gonna join them, and we're gonna join them like this, so that the middle part of the space is thicker than the edges. All right, this is the radius again. Now the difference is that along with principal axis, this is the same axis that we've discussed about in the case of mirrors, but here we've got another axis. Okay, this time principal axis was basically a line, okay, traveling through the centers. All right, but in this case this is a plane. This is not a line, this is a plane which is placed perpendicular to the principal axis and to the surface of these mirrors. All right, now you're getting my point. This is a line, principal axis is a line passing through the centers, but this one we call it vertical axis or plane, principal plane and all that. Okay, so this is a plane, this is not just a line, this is like a paper just struck right in the center of this mirror. Okay, same is the case with the convex lens. In this case the plane passes through the centers, cuts this lens into half. All right, now you've got it. In this case, in case of convex lens and in case of concave lens, remember that there is no center of curvature. All right, because if there was a center of curvature, then it should be at the same distance, but we see that as these are two separate spheres, there is no one sphere. Okay, there are two separate spheres, so it might be possible that this sphere is larger than this one, or this one is larger than this one. In both cases, the distance of center of the sphere to the center of this lens would be different from this distance of center of this lens to the center of this sphere. All right, that is why we don't have an object the center of curvature in case of lenses. Then what do we have in case of lenses? I'll tell you when we reach our second diagram. All right, for now This is a concave lens and this is a convex lens. Alright, coming to our second diagram. If there is no center of curvature, then how would we define a focal length? Alright, focal length is half of the center of curvature. If there is no center of curvature, how would we determine where the focal lies? The focal point lies. Alright, so it turns out that as there is no center of curvature, but we are gonna use 2f, 2 of the focal length. Okay, so that if we are given the 2f, then we can easily find out f by dividing it by 2. Okay, so this is called 2f, the distance of center of the mirror, center of the lens to the double of the focal length. Okay, now if we divide this distance into half, then it becomes the focus, and again if we divide this whole length into half, we get to the focus. Okay, second thing is that you already studied that in case of mirrors we had one focus, either on the same side of the mirror or the opposite side of the mirror. But in this case, in case of lenses, we have two focuses, okay, or two foci. The plural of focus is foci. Okay, we'll have two foci here on either sides of the lens. Similar case is with the concave lens. Okay, we have two focus, focal lengths, and we have two double of focal lengths. All right, instead of center of curvature. Okay, central point is called O. All right, center point of these two lenses are called as O, or just the center of the lens. All right. Now, as there is no center of curvature, there won't be any central line, a C ray, while we are tracing the diagrams. Okay. Now, coming to the bending of light, or the focus of light, or just dispersion of light when it strikes these lenses. In case of convex lens, what happens? It just happens like in the case of mirror, but the image formation is just on the other side of the mirror. Okay, now in this case, a ray of light comes perpendicular to the surface of this lens, strike this lens, and gets converged, okay, or gets focused to a point behind the lens. Okay, we know that for convex lens, the images are just made behind the lens, just like in the case of mirrors, these are actually made behind the lens, right? But in case of mirrors, we saw that after striking the surface, the actual diagram ray would just gets reflected back, and we have to draw the you can see we have to trace it back to get our original image. All right, but in this case, this is just as simple as the case of concave mirror in case of the mirrors. All right, the spherical mirrors. But in case of lenses, convex lens is the simplest one. All right, so these are just opposite to one another, the opposite cases. Now consider the same case with a concave lens. This one is pretty much tricky for you. After striking the surface, what happens? The rays will just start to disperse off. All right, you can see if I could just zoom in here. Okay, now it's clear. This green ray strikes the surface and gets dispersed, because refraction is a phenomenon is occurring here. All right, there won't be any reflection over here. It will just pass through the lens like this. Now if there is no intersection point after it gets refracted, where would the image would be formed? Simple. We are gonna just draw these lines or trace these lines back, just like we did in the case of convex mirror. Okay, the only thing that is different is that it's not a convex mirror, it is a concave lens. All right, in the case of convex mirrors, we used to just trace back the lines, and in case of lenses, we in case of the concave lenses, we used to trace them back. All right, so this is just a difference of convex, and now here we have concave lens. All right, we just trace back these lines and we'll get intersection point, and this is at this intersection point the actual image would be formed. All right, so this here we have again f and 2f again. All right, now coming to our second point, image formation and ray tracing for lenses. All right, this is very important point because in the next topic, in the next lecture, you're going to learn about the the lens equation. All right, so to learn about that or to get the hang of that, you will have to actually understand what is an A ray, an O ray, and F ray in the case of these lenses. All right, so coming to our points, in the case of mirrors, we had studied four kind of rays. All right, but there is no center of curvature right there. All right, so there won't be any ray passing through the center of curvature, so it's definitely we're not going to use that kind of ray here. So we are just left with three kind of rays. The P ray now has become the O ray. Okay, we know that when P rays strike the center of the mirror and gets reflected back and all that, but this is the case, same case of P ray, or now we're gonna just call it as O ray. Okay, it's gonna act just like that, but it won't get reflected in this case, it will get refracted. Okay, so okay, now there's a question, why is this line passing just straight and not get refracted? Okay, simple case is that this is the central point of this lens. All right, after passing through the central point, this central point acts as a plane mirror. The exact central point acts as a plane mirror. So after passing through this plane mirror, no refraction occurs, and this ray would continue to just travel in this original direction. All right, now coming to these three rays, the A ray would definitely first travel parallel to the principal axis, then after striking the lens it would get refracted and would pass through the focus. Alright, this is the focus. The second ray, the O ray, passes through the central point. Previously we used to call it P, now we're going to call it O. Okay, so that's why it's called O ray. It would pass through the O and it would be traced further, and there won't be any refraction over here. Okay, the third one is F ray. The F ray first passes through the focus, and then after striking the lens it would get parallel to the principal axis, and all of these three rays would meet at a point that would be the intersection point, and the original image would be made, or actually it would be obtained from here. Okay, this is the point where the image will be formed. Okay, so in this case the image will be inversed, all right, the same size, but it would be inverted. The opposite is the case with the concave lens. All right, we have a principal axis, we have a principal plane, but in this case we see that the ray diagram is kind of really confusing us. So we're gonna just zoom it here. These are actually just the same three rays. Okay, but in this case we're just gonna trace them back to get our intersection point over here. All right, the first one is A ray. It would just strike the lens, okay, and after striking the lens it would get dispersed, okay. It's gonna just flow away, it's never gonna meet any line again, okay. So how are we gonna get our intersection point? Of course we will just retrace this line back and get it right here, okay. We're gonna just trace back this line again. All right, the second one is the f-ray. The f-ray first passes through the focus and then parallel to the principal axis, but we see that after striking this it gets parallel. So when did it strike the focus? Of course, when we would just redraw this line over here, we see that it was passing through the focus. Alright, its original direction was towards the focus. But after striking this lens, it got refracted and got actually parallel to the principal axis. Okay, so first it was traveling in the direction of the focus. Then after striking, it changed its direction and got parallel to the principal axis. Now, after refraction, if we just redraw this line over here, we get intersection. But we need a third ray to just confirm our intersection point. Okay. We just want to make sure that we are not doing anything wrong here. Okay. We've already got an intersection point over here by using the A ray and by using the F ray. Now considering the third one again, the O ray. It just starts at the point where the object lies, passes through the center, and again it would just continue its journey without refracting. Okay, so we're not gonna just retrace this O ray, because if we would just retrace it, it's not refracted at any angle. Okay, so it would be retraced to its previous direction, right? So there's no need to retrace an O ray. Okay, so we see that this ray, and this ray meet at a point where the image would originally be formed. All right, if you just see these were dispersed, but in case of concave lens we have to retrace these lines in order to get the intersection point, which is the actual point where the image shall be formed. All right, so you see that we used to do this in the case of convex mirror, okay, but here we're gonna use this kind of geometry in the case of concave mirror. So this is just the opposite as the case of mirrors. All right, thank you so much. This was all for today. Take care.